Every matrix stretches or squashes space. Two questions follow naturally. By how much does it change area, and can the transformation be reversed? The answers are two of the most useful numbers and ideas in linear algebra, the determinant and the inverse. Start with a simple picture, the unit square 1 by 1 sitting at the origin. Apply a matrix and that square becomes a parallelogram. The determinant is simply the factor by which its area changed. If the area triples, the determinant is 3. If it stays the same, the determinant is 1, one number capturing the stretch of the whole space. For a 2 by 2 matrix, computing it is easy. With entries A, B on top and C, D on the bottom, the determinant is a times D, minus B times C. Take the matrix 3, 1, 1, 2. 3 times 2 is 6, 1 times 1 is 1, 6 minus 1 is 5. So this transformation multiplies every area by 5. The determinant can also be negative. What does a negative area mean? It means the transformation flipped space over like turning a page. Orientation reversed, what was clockwise is now counterclockwise. The size of the number is the area factor, the sign tells you whether space got mirrored. And the most important case of all, a determinant of 0. This means the transformation collapses space, squashing the whole plane down onto a single line or even a point. Area becomes 0. And here is the crucial part: once space is flattened, you can never unflatten it. Information is lost forever. That connects directly to the inverse. The inverse of a matrix is the transformation that undoes it. Stretch by 3, then the inverse shrinks by 3, and you are back where you started. In symbols, a matrix times its inverse gives the identity, the do-nothing matrix. But an inverse only exists when the determinant is not 0. Why do we care? Because inverses solve equations. A huge amount of machine learning and science comes down to solving a times x equals b, find the input x that produces output b. If a can be inverted, the answer is clean, x equals a inverse times b. Undo the transformation and read off the input. In machine learning, a 0 determinant is a warning sign. It often means two of your features are redundant, perfectly correlated, carrying the same information. The matrix becomes singular, non-invertible, and formulas break down. The determinant quietly tells you whether your data is truly full of independent directions or secretly collapsed. So, determinants and inverses. The determinant is the area scaling factor. Its sign tells you about flips, and 0 means space collapsed. The inverse undoes a transformation and exists only when the determinant is not 0. Now for the crown jewel of linear algebra, the special directions a matrix leaves untouched. Chapter 8, Eigenvectors.